So now looking at the last couple of questions on Chem Activity 1, I'm going to jump through question 13 and ask where we're going to find most of the mass of an atom, and that is the nucleus. It's inside the nucleus. And the reason for that is protons and neutrons are much larger than electrons. They weigh a whole lot more, and they're also bundled up in the middle, while the electrons that are tiny are whizzing all around the atom in a much greater space. And looking at this exercise here, you just need to fill in the gaps, and if you know two of these, you should be able to find out what the others are. So it's just basically using mass number and atomic number. The mass number is the total of protons and neutrons, while the atomic number is the amount of protons. So you should be able to figure out, well, the mass number, you know that here is 31. So you should put in 31 here. And by knowing that you have 15 protons, you will also have 15 electrons. And you can all see that because this element here is neutral. So you do the same thing here. If this oxygen is neutral and it has 8 electrons, well, then it's going to have the atomic number 8. When looking at these questions right here, it wants to know the mass in grams. And so we're looking at some very common isotopes here as hydrogen 1 and carbon 12. And you have to scroll all the way up where it says here 1 AMU, which is atomic mass unit, which this much in gram. And doing this exercise, you can look at the specific AMU, which is how much one hydrogen with 1 proton will weigh in atomic mass units. Or you can just assume that hydrogen 1 has 1 AMU and that carbon 12 has 12 AMU, which is actually what it does, since AMU is based on carbon 12. So if it makes it easier for you to just think, okay, 1 particle in the nucleus, that's 1 AMU. And this one has 12, so it's 12 AMU. Well, if that makes it easier, do so, and then just do the math the easy way. And so you need to take the amount of AMU that you have and multiply it with that first number you got right here to get how many grams each of these isotopes weigh in grams. And so the same way you can do that calculation for methane, which you see right here. And so you need to calculate with how many nucleus particles you have per carbon and also per hydrogen. So it just becomes a bigger math problem, but still the same thing. Find out how many AMUs you have here and then multiply it with that number. And these are some definitions, and right here, if does this oxygen contain the same number of protons, neutrons, and electrons? No, it does not, because oxygen has 8 protons and that leaves 10 neutrons.